Question 12. The curve has the equation y equals 12 plus x squared root x all over x, and x is greater than 0. Part A, express 12 plus x squared root x all over x in the form 12x to the power p plus x to the power q. The first thing we can say here is as x is greater than 0, x is not 0, and so this function is defined. Let's consider 12 plus x squared root x over x. If we split it into the two fractions, it gives us 12 over x plus x squared root x over x. Notice this only works when it's divided by x only. If the fraction was upside down, x divided by 12 plus x squared root x, we couldn't simplify that. Let's now look, and 12 over x is 12 times x to the power minus 1. 1 over x is x to the minus 1. And if we've got x squared divided by x, that is x times root x, which is x to the power of half. And if we add the powers, we'll have 1 and a half, which is 3 over 2. So we've got our simplified version. Part B, Part 1, hence find dy dx. So we have to differentiate our function. So let's look at things. Y is equal to 12x to the power minus 1 plus x to the power 3 over 2. So this was handy that they asked us to write it in this form in the first part of the question. Differentiating, so we've got 12x to the minus 1, so the power is minus 1 times 12 is minus 12, and the new power is 1 less, x to the minus 2. Now look at x to the 3 over 2. If we differentiate it, we get 3 over 2, which is 1.5, x to the power 1 less than 3 over 2, which is a half, or 0.5. Part B2, find an equation of the normal to the curve at the point on the curve where x is equal to 4. So we want to find the equation of the normal to the curve, but we know the gradient of the curve. We found the gradient of the curve is given by minus 12 x to the minus 2 plus 1.5 x to 0.5. When x is 4, y is minus 12 over 4 squared plus 1.5 x to the power 0.5, which is the square root of 4. Minus 12 over 4 squared is minus 12 over 16. Root 4 is 2 times 1.5 is 3. So this is 3 minus 12 over 16, which is 3/4, or 2.25, or 9 over 4. We know the gradient of the normal is perpendicular to the gradient of the tangent. The gradient of the tangent was 9 over 4. We need to times that by something to give minus 1, so we invert the fraction 4 over 9 and change its sign, make it negative. Gradient of the normal is minus 4/9. We know the equation of a straight line can be given in the form y minus y1 equals mx minus x1, where the gradient is m and x1, y1 is a point on the line. We know x is equal to 4 at this point, so y equals 12x to the minus 1 plus x to the power 3 over 2 is the equation of the curve. Let's sub x equals 4 in, so y equals 12 over 4, x to the minus 1 is 1 over x, plus root 4, because that's x to the power a half, all cubed. 12 over 4 is 3. Root 4 is 2, but if we cube it, we get 8. So 3 plus 8 is 11. The coordinate is 4, 11. Let's sub 4, 11 into the equation y minus y1 equals mx minus x1, and the gradient is also minus 4/9. So y minus 11 equals minus 4/9 x minus 4. Let's multiply through by the 9, so we get 9y minus 99 equals minus 4x. Minus 4 times minus 4 is plus 16. If we rearrange that, we'll have 9y plus 4x equals 16 plus 99, which is 115. 9y plus 4x equals 115. Part 3. The curve has a stationary point P. Show that x coordinate of B can be written in the form 2 to the k, where k is a rational number, can be written as a fraction. For a stationary point, we know dy dx is equal to 0. We know dy dx is minus 12 x to the minus 2 plus 1.5 x to the power 0.5. If dy dx is 0, 0 equals minus 12 over x squared plus 1.5 x to the power 0.5. Let's add 12 over x squared to each side, so 12 over x squared equals 1.5 x to the 0.5. 12 divided by 1.5 is 8. X to the 0.5 times x squared, add the powers, x to the 2.5 or x to the 5 over 2. If we rearrange, this means that let's take 2 to the power 5 of each side, so x to the power 1 is 8 to the power 2/5. So x is 8 to the power 2/5, but we know 8 is 2 cubed, so we've got 2 cubed all to the power 2/5, so we multiply the powers together, and this is 2 to the power 6 over 5. X is 2 to the power 6 over 5, which is a rational number, so k equals 6 over 5. We could use autograph to look at this question. The equation of the curve was y equals 12 plus x squared root x all over x, and we've sketched the curve. When x is 4, we found that y is 11, so the point 411 is on this curve. We could now look at the equation of the norm that we got. 4x plus 9y equals 115, which is this line here. So this green line is supposed to be an equation of the normal to the curve at this point 411, which doesn't look right, but if we think about it, our scales are different. We now make the scales equal aspects, so this 5 units there is the same as the 5 units there, and this line now looks as if this would be a normal to the curve, with a tangent to the curve running like that. The last part of the question looked for the stationary point. The stationary point would be the minimum point on the curve, so we could look to see what that is, but to get a better idea, it looks as if it is 2, 4, 6, 8, 10 as a scale, so it's just over 2, and the power of 2 we had was 6 over 5, power of 2 just over. So that would seem as if that would link in with the minimum point being there.